Today I want to talk to you about betting the farm on Rust. Hi, my name is B5. Well, I guess I'm in human space. I normally go by B5 on the internet. I work at a company called Number Zero. We're a deep tech software engineering company. We focus on delivering user agency with fully distributed systems. We'll get into that in a second. But we write a shit ton of Rust. That is one of the things that we do. We do a lot of that. Release all of it in the open. And today I want to talk to you about three things. I want to give you a quick tour of iroh, of what we do and what we make and why we believe it's awesome and you should play with it for free as soon as you leave this talk. But we're also I want to get a little bit into something that I haven't seen what I feel like is enough of, which is our theory of how to do a Rust-based startup. So you're going to have to bear with me for a little bit. We are going to do some like businessy things, I know, but it's important to sort of, in my mind, see how we thought about this, because we now have like 3 years of data on this at specific startup. And so I can give you some feedback on how that's going, which is the third point in the talk. We'll talk about how it's going. So first and foremost, let's do a quick tour of iroh. Iroh, for those of you who haven't heard of it, and I'm going to assume you haven't heard of it, is peer-to-peer that works. It's a library. It's purely in Rust. And why do we do this? And I don't know if any philosophy nerds, the etymology podcast was just between, but now we're going to talk about a syllogism, which is a conclusion based on two premises. But I want to live in a world where I own software. Again, I'm just old enough to have like been able to spend $50 and get a CD, and then I owned version 1. And if I wanted version 2, I could spend another $50. But that was really cool. One problem: modern software is networked. You imagine Figma for $50, for a flat fee for the thing. Not possible, right? You need those live cursors. Come on. And so ergo, we need peer-to-peer that works. This is our core thesis. We think that if we're going to get back to that space, we just straight up need an HTTP grade library that lets us do direct connections between devices. We think without that, we're missing kind of what I like to think of as the electric car of the internet. I know electric cars are having a weird moment right now, but like, bear with me on the metaphor. Shout out Rivian person before. But peer-to-peer has a whole history of having a whole bunch of really wonderful ideology-based people coming into it. For us, we think that this gives us the benefit that we want to focus on is not necessarily the network topology, because we do a whole bunch of GAC with relays, but specifically is user agency. This capacity that with stuff like this, you can ship software that gives more power to the user. And we think that's really exciting. For the technical side of things, we think of iroh as just peer-to-peer quick. I think that's the right way to think about it. It is the electric car of networking infrastructure again. And then I give you just a quick demo of that, just to sort of see this, so that you can like kind of get a feel. This is iroh compiled to the browser, which came out 2 weeks ago. And I'm going to create a channel, and then I'm going to put this microphone in here because I need both hands. And I'm going to invite peers, and I'm going to copy this, and then I'm going to go over to a command line and join this with the username LitTerminal. And then I'm going to make both of these things visible. And then I'm going to say, hi. And hey, look, it works. And I can go over here and I can say, hi. And like what's happening here is kind of bonkers. This is not WebRTC. This is all of our stuff compiled, talking through an encrypted WebSocket to a relay to send this back to the CLI. And this is literally like the entire Rust code base compiled with all of the Tokyo asynchronous things removed and feature flagged out, so that we can have everything run in the WASM runtime. And it is seamlessly working. And this was like a bonkers amount of engineering to get this to function. But you can have this for free right now. It's on GitHub. Yeah, so it's peer-to-peer quick. Quick tour of like the guts of iroh. Okay, I need to stop moving the slide images. We have endpoints, which are just, I'm going to quickly give you an overview so that you have a sense of what we mean by like peer-to-peer that just works. This 20 lines is a working example. And so you can see that here, cargo run. It's not going to do anything interesting. All it's going to do is print out the node identifier, which it just did, because I pre-compiled it. Everybody complains about compilation times. You just need to do it before, and then it's no big deal. But we have this concept of endpoints. This is both the server and the client side of things. You can both create connections and accept connections there. We then have a couple of other bits that are important. We use relays under the hood. And so this, unlike a lot of other stuff, it will just dynamically figure out what the best connection between two devices is and seamlessly switch between them. And so if you can establish a direct connection between two things, it will just fall back to you using an encrypted relay for sending that data. You just dial node identifiers. All node identifiers are these secret keys, which are ED25519 keys. I've gotten very good at saying that. And you just treat that as the thing that you dial. And we have resolution services in the background to resolve the keys into IP addresses, which you can dial. But at this point in the demo, when I did this, I knew my server reflexive address. And so that was the whole setup, and I'm now ready to talk to the world. Yeah, we have a couple of other bits. On top of that, we build on top of Quick's application level protocol name for multiplexing protocols. And so we have a whole bunch of protocols that we make ourselves and a growing set that are being contributed by the community to actually be able to enhance these in ways that are more important. This is where I think the electric car thing really holds, because you are you're running in a different internal combustion engine. Yes, it's still like servers and networking, but now you have to think about a lot of things that you didn't have to about before, because now every client is a server. And so now you have a whole bunch of fully distributed systems, things to think about. And so we also ship these protocols on top that you can compose together. And then we use the Quick LPN to basically be able to do multiples of those, kind of like middleware stacked in between. We can talk more about the nerd bits. I love talking about the nerd bits, but I also want to talk to you about why we do this. There's also a business case for doing peer-to-peer. We have a lot of charts internally that look like this, where, hey, all of the iroh transfer is free, and all of the cloud egress is stuff that you pay for. And we have people who are reducing their bills by a lot. So there's business reasons for doing this. We're not anti-capitalist by any means. I think it's a great idea. We should be able to create these networks that both increase user agency, but also give us business reasons for pursuing something like this. We think this is a competitive advantage. We think that you can use this to go fight incumbents, ship services and applications that cost less to run, which means that you can be more competitive in the market. Okay. Now, why did we build a Rust-based startup? This is the thing that I hope you'll bear with me on some of this, but we had to think very carefully when founding Number Zero about the decision to write Rust. My co-founder is the CTO of the project. I'm the CEO. Those are senseless titles when you're a team of 9, but it's important because it was his decision to say Rust. And if he had said COBOL, I would have been sad, but we would have gone with COBOL because trusting your CTO is important. But we went with Rust, and then I had to work with everybody building out the team to put together a very specific plan for how we were going to deal with both the compiler and the types of people that are really fascinated by Rust, which is all of you, who I am now one of those people. I wasn't when I started. We are engineering first and measurement focused in a big way. If we go to, I think I have it in another tab. Yeah, perf.iro.computer. I think I have to reload this because there was some bugs, but this is the latest commit to main. Our throughput is 2.54 gigabits on the latest commit. We put a ton of time into measuring the crap out of this and making sure that it is robust software, that our CI is just garbage crazy. We have actually started to use a whole bunch of home runners to run CI because the checks are just a little bit too much. The bill on GitHub would just be ridiculous. And so, this was always going to be the way from the jump. We're going to be very engineering focused for building software infrastructure. This is kind of you really just want to write it correctly. That is kind of the reason that we get involved in systems level stuff from the jump. Complaints I've heard from other places and other language communities, and a friend of mine came at me in my DMs with this, saying, no one who writes Rust ever ships anything, and he was being very specific. He means doesn't ship fast enough, doesn't ship at sort of startup speed, and we're going to get into that. But I don't think that he's wrong, right? I think that something that we should just admit from the jump is that we don't ship as fast. It takes a lot longer to write a Rust program because the compiler is not going to give you a binary until it's correct, right? We just have to just accept that reality into our lives. And in startups specifically, I don't know how many of you work around or near a startup. Hand up. Okay, so yeah, we're in the right crowd. You have this. This is a bit of a beleaguered metaphor, but I think if you follow, this is not like a chart through time on the left, but you have Git and it. You have nothing. You have no capabilities, and then your job as a startup is to kind of cobble together capabilities to get up to a minimum viable product. And we jokingly said internally when we were starting the Number Zero that we thought that a lot of the straight rush to build something that could test the viability of an idea looks like this. And we think this is actually that's the right way to build a startup in so many ways. So you use a higher level language, you stack up capabilities, you go find out if there's demand for the thing that you make, and that gets you the B round, and then you go build it for real, right? Let's just be honest about it. And so this janky ass thing lets you just test out, hey, does the world want this, right? Now, we joked internally that this is what it's going to look like with Rust, where we have this really killer, super awesome foundation that just it worked in every situation, but in no way did it get us to a place where we could understand or even test out some of these ideas, right? Like we're writing HTTP, like we're writing like a networking library. Like what the hell are we doing? How are we turning this into a startup, right? And like most importantly, like how are we going to deal with this? And we could talk about cap theorem, but instead we're going to look at another trilemma that is a little more common outside of our circles, which is the time, money, quality triangle, right? And the thing that I want to put to all of you is that this might feel, maybe you'll be nodding along, maybe this is like, yeah, this is where error, but like Rust just hard requires you to check off the quality box, right? Like the compiler is saying like, hey, you will not get a program that compiles unless it is memory safe, means that the software that you just like hello world yourself into is memory safe, is consistent, is correct in a way and on a level that most software isn't. Like all of us have seen a lot of other languages and a lot of software, and like once your brain sort of starts to wire itself around the borrow checker, like you start to look at the world in a different way, right? And so you just have to deal with the fact that in this trilemma, you are always and forever going to be winning in the bottom right, and you're going to have to manage the other two, the time and the money. And I'm going to posit to you that the one that you really need to worry about is time, because I don't know if you've ever heard this complaint about software engineers, that their ability to sort of like estimate how long things will take is something. You've heard that? Okay, good. And I think you have to solve for these, right? And so we're going to get more into the money bits now, because you may or may not be venture backed. There's a whole contention around here, but like I think there is also just, I want to zoom out a second before we even get to the how our team answered the time question, and talk about some of the other sort of like factors that weigh in on this. Typical venture capital firms measure their funds in 10-year fixed terms. And so what they do is then they take that and they split it in half, and they spend 5 years investing in 5 years. I don't know what the technical term is for it, but it's like making money. I don't know, whatever that second half is. But in all honesty, they're doing important things and like trying to figure out whether they should reinvest or follow up. And that means that your life happens in these like 2 years, right? Because it sort of is that 10-year term becomes part of the reason why you need to grow 20% quarter over quarter, month over month, whatever period you measure, right? Because that's making sure that you're showing the growth to qualify as high growth, to be worthy of reinvestment. And like on our side, we're trying to build like really correct, slow stuff. And so there's this real grinding sound between correct software and this 2-year thing. And so we had to think very carefully. Like, honestly, I've spent a lot of time building companies and software. And like, when we were talking about this, it was like, how do we close this gap in 2 years? It was like the big question. And the fundamental conclusion we came to was that like, okay, yeah, this is how we want to approach it. We want quality, slow is smooth, smooth is fast. Okay, like how do we turn this idea into a thesis of a company? And so the first thing we did is time, money, quality. This is a trilemma. We cannot just like code our way out of this. We can't just be like, oh, we'll work extra hard. Like, no, we have to find a way to add time to the clock. And so for us, what we ended up doing is we, as a co-founders, put up some cash to put 2 extra years of runway where we just went and built stuff quietly, which was a giant risk. But my thesis on this is if you're going to start a startup, startups have like 115% failure rate or something. And so like, what's an extra 2 years? You're already all in. It doesn't like really affect things that much. And the other thing is we put up some cash. You do not need to do this. If you're considering starting something, this is where like, just like ramen profitable, like testing an idea with either maybe you write first in a higher level language, maybe you write just out of passion on weekends and on the side, and you don't worry too much. You try to get to the MVP just through Rust because it's just what you want to write. Both are substitutable for what we did. We wanted to build an HTTP replacement, so we needed engineers, period. And so this is how we came up with it. The other bit is still stopping the bleed of the compiler. And for this is going to sound really contentious because I have up on the slide, it says no junior engineers. So I'm going to like caveat that a whole bunch, but like honestly, this was a big part of starting this company. We are a team of 9. Every single person on the team has a minimum 3 or 4 years of Rust. Most of these people have shipped mission critical dependent stuff. Like I'm not joking when I say that it is the single greatest honor of my career to work with these people. They are stupid talented. And a lot of that sort of derives from my co-founder, who is not here, so I get to big him up. But if anybody tells him that I'm saying this stuff, I'm going to be very angry at you. But he's a bona fide badass. Like, he maintains Arch PGP. He's written an RSA implementation in pure Rust. He works on a core STMP server for chat. If you look on some of his download figures on crates.io, he's got crates that have 46 million downloads. It is not ours. It's not iroh, I should say. But we really, I was not comfortable founding a company and going on Rust without this caliber of co-founder, specifically because he came in with a certain aura that allowed us to attract and retain some of that other talent, right? We had people who just sought us out purely because they want to work with Dick. And that was nothing to do with Schmucky the Clown, who you currently have to listen to, which he would have been a better speaker, but he's in Germany. And my whole reason for really wanting to focus on these engineers who have a silly amount of experience was you do get past a good Rust engineer does buy back those first two. Why does this compile, right? And I've run into this as I've acquired knowledge of the language. It's oh, because I'm thinking about it wrong, right? And you have that moment where you're not actually. The compiler is telling you, no, you literally can't hold that memory the way that you're trying to hold it. You have to re-architect this. And this was the thing that we specifically wanted to avoid. We wanted to make sure that everybody on the team kind of got us past this so they could use that time to complain about async Rust. That was very important to us that we invest silly amounts of money in complaining about async Rust. But we will hire junior engineers. We are growing towards that. And as someone, I really care about education. I really care about growing. But in the meantime, the whole thing is open source, and we spend a lot of time on our Discord just working with people who are skilling up. So it's not like we're ignoring this, but from a practical perspective of how are we going to pull off a startup in Rust, we had to take this very seriously, and we had to make sure that we hired accordingly. We hired very slow, and we very intentionally. We aren't hiring. There's no jobs page for us right now. If you want a job at number 0, you just be a freaking badass on the internet. We will find you, and that's kind of how we do our recruiting, right? It's very slow right now. Slow is smooth. Smooth is fast. Yeah, we've been over this. Lots of startups fail, and so I guess the next question is how's it going, right? So the reason I'm excited to give this talk now is we're at a very specific point as a project where I don't spend a lot of time staring at this graph, I promise, but this makes me pretty happy. I'm not gonna lie, we're having a bit of a moment right now. And the reason we're having a bit of a moment right now is we spent 2 years building stuff, and you can see this was the long and the slow and the boring time. And then we sort of started to figure stuff out, and lately that quality thing has started to kick, right? We now are getting to the point where I can show you, it took us so long to get to 20 lines, right? You should have seen the first iterations. It was total garbage. The version 0.16 of iroh had 4 protocols that you could only have. We didn't really know what we were doing. We genuinely did not have this figured out. We're very proud of this. This was a ton of work. And it's starting to show, right? We're starting to actually get to this point where people are able to adopt it. We are now at the point where we're seeing 3 or 4 new projects emerge per week. And it's really fun, but it's sort of we have more than 10 million devices running iroh right now. We have a bunch of GitHub stars. We have a lot of projects building on top of us. I think I've listed that twice. That was supposed to be contributors. It's somewhere in the 40 to 45-ish contributors. But things are coming along. I put this up now because, talk to me in 3 weeks and it'll not look like this, and we'll be, it's already kind of going, wow, we have to go do some marketing. But we've got a bunch of people growing and building on top of us. The number of use cases is kind of bonkers these days. We've had some peer-to-peer chat applications. We've had machine learning distributed around the world. We've had a file explorer. We've had a bunch of the Rust game engine world pick us up. We've had a blockchain launch on us. We've had live video streaming built on top of us. I think hopefully this won't play with sound, but just to give you a sense, this is a direct connection between 2 devices. This is a company that does game streaming, and the laptop there is actually rendering the game and sending back the controller input that he's playing. So this is the Google Stadia, just peer-to-peer. And it just blows my mind that is C++ code being compiled, being FFI'd into a Rust quick library, peer-to-peer to that thing. And it's a really stunning feeling to actually have the synchronization between the controller stream and the audio and video stream all line up. And doing that through a boundary on a phone with a laptop, this is stuff that I hadn't really seen before. And it was really fun to get to work on this. And satisfaction internally, I just quickly pulled the team before putting this talk together. How is, reflect on your time writing Rust. And satisfaction internally is just through the roof. People are pumped. Like, yeah, you'll hear the day-to-day griping about Tokyo, and my frustration lately right now is the unmaintained warnings from cargo deny. But it's overall, the language has been amazing, and the sense of tending to a garden when you get a code base up and into a place where you've like purposefully built an organization around long-term stable maintenance of what will hopefully become critical infrastructure is a very rewarding process, and like has been a lot of fun to work on. And so, yeah, that's kind of it. Some other high points: you can go fast once you go slow first. We have had like, hey, what's going on? Nice to meet you. And like in the Steam store, we did that in 3 weeks. And that was like with an open source collaboration with the Bones folks. And I think, you right, Russ, you have this new superpower that you now know about because you've come to this talk. You have peer-to-peer that works. Other people have a way less fun time doing it because their FFI bindings are, and they need love. But yeah, and manage your time well so you can complain about async. I think that's it. We can. The question stuff, I can answer questions about the technical details, but I'm not like one of these doofy CEOs who does not know anything about the way the guts work. But
one of the first things that always worries me when using third-party libraries stuff is security. So since you mentioned the browser, and I'm presuming you're supporting WASM or something along those lines, yep. Have you considered supporting bindings via WASM so that companies could use, say, Go with minimal format to user software? And in this way, because WASM is basically just protecting their infra, they can use you solely for transport and kind of sidestep worry about you spying on whatever they're sending.
Totally. So I should say that the Edwards curve key created here, the reason we include this, you can actually drop this and just do secret key, but we intentionally put it in to, this is the actual encryption key for the connection. And so like the connection is end-to-end encrypted, like literally, like you are the only one with a key. And in this instantiation, when the process dies, that's it.
Sorry, I should have been more specific. Worries about your library since they'd be including it.
Right, touche. Yes, so our compilation target is WASM 32 unknown. Currently not doing the other version, but yes, WASI, thank you, and the WASI component model GAC. We actually have for Node.js a set of Node.js bindings, but yeah, so is it useful that way? Yes, absolutely. Is the software supply chain attack concern real? Yeah, it's real, and we'll continually audit that. But yeah, I wish I had a more strong answer for you beyond we really pay attention to cargo deny, and it's an open source project, so you can take a look at every line that's in there.
Thank you.
So can you give some information about WebRTC? So like questions like, is that really the best approach? Are there alternatives? How much load are you able to do? How many sessions can you do simultaneously? What kind of overhead is that? Because typically if you host in the cloud, it's very expensive.
Right. Yeah. And one of the biggest things it comes down to is what we lovingly refer to as the hole punching rate. If the expense you're talking about is cloud egress, right? If you get into it, I'm going to have to, if I remember correctly, my numbers for WebRTC's hole punching rate, they're generally in and around 80%. Mileage really varies based on the amount of corporate firewall you're doing.
Can you get a lot of, do you ever get sessions that don't work because of the firewalls and people blocking RTC?
And so we do, if you're doing, so iroh has two methods of establishing connections. It will both do, you can configure it to use MDNS, so that can do like completely walled off from the internet, just find somebody on your local router and talk. And then you can also, that is an opt-in configuration. By default, we use relays for everything. If you can establish direct connection, literally we will take packets as they're flowing and flow them through the relay. Like you will not see the flip-flopping unless you pull for changes.
So you use different codecs, like for
it's
AB1?
all quick. The whole thing under the hood is entirely quick, with the exception of this thing on top of it that is kind of like a magic endpoint that maintains and flip-flops the connection. The ongoing work that we were working on before our 1.0 release, which is planned for later in the year, is quick multipath, so that we can actually fuse multipath quick and the quick congestion controller with a lot of this switching between relay, not relay.
Yeah.
It's we have 2 people who have been working on it for 2 months and are very tired. We're trying to upstream that into Quinn. Quinn is our library of
So
choice.
do you use a cloud hosting service to do the WebRTC? Like, are you paying?
Yeah, so we run Sun servers. Part of our business model is we work with partners and we help them deploy relay networks. The relays are also open source, so you can run your own. There's no like, oh, that part isn't allowed. And so, yeah, and generally our hole punching rate is higher than WebRTC's. And so we have had people come to us and switch off of WebRTC to get a savings specifically because we have a better hole punching rate.
So did you have to do load balancing across different locations to be able to handle the latency?
Peer-to-peer. Load balancing isn't really a thing.
Okay.
Our relays, we have seen in the live production worlds, our relays doing up to 500,000 simultaneous connections.
Wow.
We have, but with peer-to-peer, like that's just like, hey, what's going on? Let's flip to direct, right? And you're seeing that. So like usually 90% of traffic is flowing between the devices. And so you can do silly scale with this stuff.
So the end user controls at a distance have been pretty good. There's
pretty
responsive.
The Chaga folks that are doing the game demo have run that over 300 kilometers of ground distance.
So what kind of latency do you get at 300 kilometers?
Sub 50 millisecond ping.
Amazing.
Yeah.
Yes. I think it's worth a quick clap while I walk to the next question. That's pretty crazy.
I mean, your mileage will vary. It depends on where you are and what your connection to the internet is, right? But like we have seen that happen for real.
So can you tell us a little more about these relays? Like, are they run by your company? Are they run by random volunteers? If I start up and over this, is it going to be some random person's relay?
Yeah.
If I start my connection, whose relay is it going to use, etc.?
Yep. So we have both the discovery number 0. We intentionally label this N0. This is the discovery service, which you didn't ask about. But this relay mode default, if I hover over this, which is use the default relay map with the production relay servers from number 0. So we provide with the library a set of relays. This is very easy for us. I can tell you point blank, the bill for these is less than $700 a month. And so like we run this infrastructure. This is the value of near zero networking abstraction, right? We have near zero data copying. What happens when we can actually do direct connection between devices? We can offer this service for a long time. Now, as I mentioned, the relays, like if we go to, I can actually show you the relay binaries, but they're here. They're in the release every time, right? Where's the relay? It's in there somewhere. Anyways, it's there. So you can just download and run it yourself. So most of our power users that are deploying this in production are always running their own relays. The public relays are rate limited on purpose because it's a public service. It'll still work. It'll just slow down if you try to jam movies through it. But yeah, a lot of our folks we work with, we help them deploy their own network, but you can deploy your own tomorrow. And we include instructions down in it's buried in a README in the relay crate in IroNet.
So I might start my own relay and maybe optionally it registers with you and someone else might go through it, or maybe it doesn't register with you, no one else knows about it.
Yeah, this is where we kind of maybe divorce from some of the peer-to-peer federated stuff. We intentionally believe that you should be doing one network per app and that your app should have its own infrastructure. There's 2 reasons for this. One is because you really want to be able to have control and visibility into that as a programmer, but also it means that every peer you talk to is valuable, right? You don't want to just like be talking to random people on the internet. You want to have, hey, I'm going to dial this person for this app use. And we think that dramatically increases the utility of a peer-to-peer system, is if you've purpose-built all the nodes to want to deliver to each other valuable data, streams, et cetera.
Do you use the system MDNS stack or do you have your own?
We use a library that gives us an abstraction over MDNS, which does use the system MDNS stack with some twists that we intentionally...
Does it deal with the Android bullshit?
GAC nonsense? Oh, Android. I can tell you stories about Android. Network change detection in Android. Anybody want to visit a certain circle of hell with me? That's another thing that there is no like thing. We have to like do all that ourselves. Yeah, that's part of the cross-platform nonsense. Cool.
Just a quick question. Is there a distributed hash table kind of thing or?
DHT stuff. We definitely do DHT interaction. We have a very strong opinion about DHT. It's not always popular. DHTs are 2 components. One is writing a really good DHT implementation. So for those people who distributed hash tables are, hey, I need to store more hashes than I have space on a computer. Or I want resilience because maybe I'm trying to do something that might get shut down for reasons. The other thing you need to make a really healthy DHT is lots of nodes. And so we actually do a ton of examples that work with the BitTorrent mainline DHT. We find it great, mainly because we've seen other implementations that are not great. We've seen sub-second resolution of records consistently from the mainline DHT, and it's often north of 1 million nodes, which is that second half that we really care about. So we try to be pragmatic there. We do have some folks building distributed hash table implementations on top of iroh in the open. Often we really, when we think about fully distributed systems, what we really want is that self-healing property. There are other ways to inject that property without necessarily relying on hash-based overlay networks. I could totally talk about that for too long.
So are you guys venture backed at this point?
Yes, at this point.
Can you speak more to like your experience of navigating the funding? Because this is like a different from what most investors think about SaaS, like a software. So probably sharing that experience.
I want to do open source user agency investments. There are actually people that care about that, and you can find them if you work hard enough. We have some really good mentors in the space, particularly if you're going to do an open source play. I intentionally tried to carve away from the open source conversation today because it's a whole nother can of worms. But we have meaningful revenue, and we got to meaningful revenue before doing any fundraising. And that was intentional. We needed to prove that we could sort of show both sides, that we could both build a business and we could develop and proliferate an open source project. But yeah, and that a lot of that is basically peer-to-peer is hard still. We're trying to make it easier. And honestly, our long-term strategy is to end up in a place where you have a Vercel-like thing where you can just spin something up that will always be based on convenience, that will not be based on some lock-in. I love Vercel and I hate Vercel because there's reasons. But yeah. There's someone else. Yeah, I just want to make sure that we. Yeah.
Just a quick question.
Yeah.
Hey, thanks. I was wondering, how do you see this compared to like TailScale, like maybe from the business side of it?
Totally. TailScale, killer VPN, WireGuard rips. It's so great. We just want that in apps as a library. That's the core difference, right? We the only thing we care about is like, we have a lot of experience. We come out of the libp2p world, and so which is a great library that was very Web3 focused. The thing that it gave you is this modular stack of protocols that you could stack on top to really quickly compose functionality. This is really common in the HTTP world where you have HTTP middleware, right? Cool, I need OAuth, plug that in. I need Rocket handlers, cool, NBD. But like we don't have that in peer-to-peer, right? And that needs a complete this is the electric car part where we have to go think through, well, shit, everything. How do we do with all of this? And so that's where we come in, and how we distinguish ourselves is really, I think TailScale rips. I think it's fantastic stuff. We intentionally don't really touch too much on the like home server hosted stuff or the like corporate VPN world that's very much where TailScale is just like phenomenal and better in my view. We are also a Rust project and not a Go project. And so that is one. And where that really matters is phones, right? Like iroh is running on millions of phones, and that's partially because the memory overhead and the sort of performance overhead of not having a garbage collected language on a mobile device is a pretty critical differentiating factor.
Very quick question. Some bigger companies are obsessed about certification of all sorts. How you're doing on that?
SOC 2. Like, are we talking like SOC 2? We're talking like
also like
the
there's
acronyms.
So much. Yeah, exactly. That's everything.
Yeah. I've had my sales calls with Vanta. It's going great.
I'm sorry.
But yeah, no, it's honestly, it's a thing. And particularly for us, our engineers are all over the world. And so like there's a whole bunch of overhead for us in forming a sub-entity and the people who are allowed to touch compliant data. And yes, that is absolutely a process that we're currently working on.
Excellent. Thank you.
I don't know if that helps go long.
Hey, nice talk. So I was just wondering if you could make it a little bit concrete for me. You showed that diagram of cost versus cloud egress.
Mm-hmm.
And then most of the things we talked most of what we talked about is mobile apps. I'm wondering if you could give a couple of examples of where does that savings come from? Is it data? Like I'm sort of trying to think how I would.
How does this work?
What does it do? Like, it sounds great, but like, how do you get these savings? What does this mean?
This is the crazy characteristic that is very hard to get your head around with peer-to-peer systems. Imagine every single user of your app was a server, and that the core thing that makes this trick work is Verizon has to provide public whatever egress between devices. So when data transfers between, and most importantly, like if you think about it from like just like an efficiency perspective, one of our chief use cases is synchronizing your phone to your laptop. And why are those bits going to Virginia East and US West 2? Like that doesn't make any sense. Like just like rationally, why are we synchronizing to the cloud every second, right? Why aren't we just like the best connection you have is the one from your phone, potentially to your router. If you're using the OWL protocol that I'd like to support one day, it's just going directly between the two. On Apple devices only, lobster traps, problems. But like that's what makes this chart work, right? And the thing that is really hard to get your head around, like once you see this for real, it's mind-blowing, because often people come back to me with like, oh, well, now you're offloading all of your work onto your users' devices. And to that, my response is your users' devices are downloading 2 megabytes of ads to see a CNN article. Like we are sending 1 request per device, right? Because every time you add a user, you're adding scale. And that's the ridiculous characteristic of this, right? And if you get into network theory, it's having the terminal units of the network be shaped the same that makes this whole thing possible. And the thing that we're kind of beholden to right now is when bytes leave the cloud, you get a bill. And that's what this chart is meant to sort of like articulate. And that's what a lot of our technology is focused on from the business case.
I'm sure a couple of companies are using this technology. Companies, gaming companies. Could you describe what that looks like for those companies?
Yeah, totally. You want to talk about Fishfolk specifically? Fishfolk was super fun because they don't want to run game servers long term, right? They want to think about like the sustainability of their software, and they want to be able to say like, hey, Fishfolk and Jumpy, which is the game's engine that it's built on, which is a fork of Bones, is going to work really well long term. And so they have this peer-to-peer setup that just lets them do game sessions, and it's in the Steam store. And so that was their use case. Recall is a blockchain. We are very compatible with blockchain ethos and things because they have self-sovereign things built into them. And so we just naturally pluralize with that whole world. Rave is a video streaming tool. A lot of that is like just like that pure like WebRTC. Hey, we need to do the hole punching rate directly affects their bottom line. Noose Distro is machine learning tooling. They straight up could not do some of this, where they figured out some great techniques in the LLM training space where they can actually not need to train specifically on servers with like 10 terabit link between the GPUs. And that's their magic. But they needed to be able to sort of like get that out into the market. And so the way they did that was with iroh. Space Drive is synchronization, like a file sync Dropbox competitor. And so they really benefit from that local sync trick. And that allows them to ship software that just has the magical synchronization vibe of Dropbox without Dropbox's overhead and the whole thing that comes with that. And then Delta Chat is easily my favorite. They are being used in lots of places where you have to be very careful about which servers you talk to on the internet. They're used in precarious parts of the world. And so having peer-to-peer technology built in means that they can be careful about what servers they contact and keep connections direct, which gives that whole user agency thing its core sort of tenant. That's also they're also a really killer open source project, fully in Rust, and support like they support like iOS 12. Like it's bonkers, but yeah. I don't know if that helped color that in.
Everybody give it up for Brendan. That was awesome. Oh, wait, Brendan, if we want to like and subscribe and smash that like button.
I promise I would never say that.
And hit the
like
bell icon. And, yeah. What's the YouTube channel here?
Oh, God. Just go to iroh.computer and click YouTube.
All right. Excellent. All right.
Hey, I'm Cole. I organize Rust East Coast events and help publish these talks with captions. Join our Discord to suggest future talks, attend virtual events, and connect with others. We'd love to have you.